All right, so I wanted to do a video on this electronic thing called a thermistor. It's a thermal resistor, I guess you would call it, right? And what it what it does is it actually allows voltage to pass through, and then it heats up to a certain temperature, and then it turns off that voltage. And really, where you're gonna use this is on the John Deere's. They have a thermistor in place, so when you go to start up the machine, it's going to allow 12 volts to your fuel shutoff solenoid. And the fuel shutoff solenoid is just there to turn the machine off, or and turn the machine on. Allows fuel to pass through, and then of course when it's off, it prevents fuel from passing through and turning off the machine. So it's a simple system. It's been around for a million years, right? It's nothing new, this technique, but there's a little wrinkle with the way these are set up on the John Deere 4210s. And this is true for probably a lot more of the John Deeres. I would say all the 4000 series, 3000 series, and even more of them. This machine here is about 20 years old, so it's definitely something they used a lot on the older machines. And when you have a problem with the solenoid and a no start condition where your throttle's all the way down and you're trying to start it and it's not getting fuel, the way you can kind of diagnose this and figure out if it's this thermistor or it's not is you can take your throttle, and if you put it halfway and the machine starts, and it starts with very low power, that means that the shutoff solenoid is actually off and the machine is running. And that is just because the shutoff solenoid doesn't completely shut off all the fuel, because the fuel is needed to lubricate the pistons on a diesel, right? So they're not gonna shut the fuel completely off, because then you can damage the motor when it shuts off. So long story short is that if you have a no start condition and this just started happening, and it's a no start when it's down on the low idle setting for the throttle, the first thing you want to test is your shut off solenoid. And when you pull the solenoid off, it's going to have 3 wires that go to it. One's a ground, one is a low voltage, which is about 5 volts, and one is a 12 volt, which is, I'll call the high voltage. The high voltage is what the thermistor is going to control, and that is there because it only comes on for about 3 seconds when you first turn the key, and that is there to pull that shutoff solenoid plunger all the way in, with full strength. And there's just a magnet in there that's magnetized with 12 volts. That does the job of retracting the solenoid plunger. And then once the thermistor heats up, it cuts the high voltage, and the low voltage is still there, right? And so the low voltage is what holds the plunger in place as the machine runs, and that's how it works. So if you kind of think about it, when you go to start the machine, if the high voltage never happens because the thermistor has an open and there's a circuit problem with the thermistor itself, you will never be able to fully pull in the shutoff solenoid plunger, and it'll basically run as if it's in the off position, the solenoid itself. So when you take the solenoid off and you bench test it, and that's what you want to do, if you find that the solenoid is working fine on both the high and low voltage, and it seems to be operating just fine and it's not sticking, 9 times out of 10 on these particular machines, it's this thermistor that's gone on it. And I can show you what it looks like, and I give you the part number even here. So I've already done this on the machine, and basically here's the part number. And in all honesty, I didn't do this on this machine, but I've had other machines, and this is a very common issue that you'll find if you diagnose that the solenoid is good and you're not sure why it's doing this. This is where I would start. So this is the part. It looks basically like a little capacitor, I would call it, with 2 prongs. And again, this is run off of thermal temperature change. So when this thing gets hot, it simply opens the circuit and no longer puts the high voltage to the high voltage line. When it's not hot, it's going to leave voltage, and that's why it's in place. Now, this actually isn't something that you can easily get to, and that's kind of the complication. So I'm going to show you where this is on this machine, and so if you do have this issue, you can very easily change this. It is going to be right behind the fuse panel, and the way you get at this, it's not that bad. The way you get at this is you take the plastic fuse panel cover off, which is these 4 bolts here, these 2 bolts actually here, and then once you do that, there's 2 more bolts on the sides on this one. You can see them here. So you got 4 bolts. You take those off. This whole cover comes right off, and just be gentle with it because it's plastic, obviously, so you don't want to break it. But once you get that off, there's 2 bolts that hold the fuse panel onto the machine, and they're down in here, you know, one on this side, one on that side. Once you take those 2 bolts off, you can then pull this fuse panel off or out enough, and then turn the right side almost like a door would open. So bring the right side out and leave the left side in, because the harness is going to be more on the left side. And then what you want to do probably before you do all this is just disconnect your battery. Anytime you do electrical work on a fuse panel especially, just disconnect the battery, because if you happen to short out something in there, it's just going to cause other issues. So disconnect your battery, and then pull this out, and then behind there what you'll see is you'll see this if you look for it, and there's 2 wires that go into it. You're simply going to cut the old one out, and you're going to splice the new one in. You can either use electrical connectors, or you can just solder it, or you can just use a crimping connector, anything that will make contact. It's not super hard to get this new one in. Once you get the new one in, before you put it all back together, take the key, you're going to turn it, and you're going to listen for that solenoid to fully retract. And then of course you're going to turn the machine on, and it should run just fine now at the low speed. So that's pretty much it for the thermistor. It's not something that is in the service manual. So if you go and look for this in the service manual, this isn't really something that is in there as a serviceable item. So it's going to be one of those things where you're going to be a little bit caught with not sure what to do. So this is something that is pretty common on these, and something I have done, and it's very inexpensive. I think the thermistor is about $10. You get 2 in a pack, so they're about $5 each, and it's about 20 minutes to change them, and that's pretty much it. All right, so I hope this helps you out, and that's pretty much it.